should be working. My hello, hello. Okay, should be working. Let me go to my live. Okay, let's try again. Hello. Okay, let's try again. Hello. Sounds alright. Alright. Let me see. For today, the worst session, we're gonna have two of them. One right now, and one is gonna be uh, it's gonna be after 15 minutes from this one. So today we're gonna work on 529, 525. Today we're gonna work on robotics. Last time we did some sketchouts about Fusion 360 and Arduino tutorial. Today we're gonna do mm, today we're gonna do sketch 360, Fusion 360. So refine Fusion 360, refine parts, and then so Fusion 360 is the same thing. So refine parts and components. Components. Implement heat sets. Hold on, someone just texted me, I think. Implement heat set onto legs, and then we're gonna do some Arduino, right? And then for the other one, 520, couldn't. So we're gonna put an ads here. I'm gonna put an ads here. I'm gonna say couldn't work. Couldn't work cause a hold was in place. Arduino, and that's it. So the next stream is gonna be on the same day, cause I couldn't do the stream from yesterday, so I'm doing today. Yesterday's stream was all about. Okay, yesterday's stream was. Oh, I deleted it. Little old me deleted it. Okay. Okay. Okay, so we're gonna Python learning, intermediate, intermediate, and then we're gonna do some lit code, and that's it. Now, of course, so my hand hurts. I don't know why. Okay, so for my schedule right now, I got all these. I had to check what's the temperature today. Temperature. What's the temperature right now? 81. Oh. Okay, I was thinking of maybe running, like 5:30 maybe. So put this thing back. Maybe run here. Then maybe go to sleep at like 12. I have a job interview tomorrow. Okay, so let's get to work. Autodesk Fusion 360. Let's open this. Uh, why is it taking so long? I don't know. Okay, reloading. I should actually clean my room. What the freak? Okay, let's go to the Etsapod, and that's what we got right now. Right now, this is what we all got. It looks pretty bad. I wish there was a way that I can learn to mate. See, I don't like this. I don't like this. It looks horrible. So if I could implement how to... Okay, so maybe how to mate. How to mate in Fusion 360.
So we're every is it elation. Simply use flip how axis and it's an important subassembly system of each. Simply flip the wrong on hole into a hole. We however if we can add cylindrical effect of a spinning are the same location. We want to make sure we use right now. And the thing is the next as it's in place, we can use what's called an as-built joint. Now, as-built joints behave the same as a joint does. However, it makes use of the current location of each component rather than selecting a location where they will be aligned. So in this case, we simply select revolute. We want to revolve our connecting rod about the crank, and then we simply pick the axis of rotation. You can see in the preview that it's leaving some of those components behind, but because they are part of a rigid group, once we start to move it, it will behave properly. So now you can see we're beginning to create this assembly. To leave a
No way.
assembly off joint, left a single option, a single joint. Also, now when we have components in an assembly, oftentimes we design them in the correct location. When we have things in the correct location, such as these bushings, we want to make sure we track that location. Fusion keeps track of the coordinate system of each component, so all we need to do is revert its position. I'm going to expand the subassembly, and I'm going to hide the crank. Do is revert its location. Fusion keeps track of the coordinate system of each component, so all we need to do is revert its location in the correct location, track of the subassembly, and I'm going to hide the crank for right now. And we want to put all three of these pieces together, the upper and lower bushing and the connecting rod. They all need to move as one. So we can do that with what's called a rigid group. What we're doing is we're telling Fusion that these three pieces move together as a single unit. Making them rigid prevents us from having to add any joints between each of those components. The next thing that we want to identify is the fact that this between their group and now, and they all need to move as all span the subassembly, and I'm going to hide the crank for right now. And we want to put all three of these pieces together, the upper and lower bushing and the connecting rod. They all need to move as one. So we can do that with what's called a rigid group. What we're doing is we're telling Fusion that these three pieces move together as a single unit. Making them rigid prevents us from having to add any joints between each of those components. The next thing that we want to identify is the fact that this component was designed in place. Because it's in place, we can use what's called an as-built joint. Now, as-built joints behave the same as a joint does. However, it makes use of the current location of each component rather than selecting a location where they will be aligned. So in this case, we simply select revolute. We want to revolve our connecting rod about the crank, and then we simply pick the axis of rotation. You can see in the to move it, it will burn its. But we also have some move, copy, and we can make those faces in alignment. We can capture its position directly from here, and we can put them into their correct location. For example, when we use align, we can align components, and we can do things like select individual faces, and we can make those faces in alignment. We can capture its position directly from here, and we can also use tools like align to go from a single point location, so for example the center here, to the center here. This will allow us to pre-position these components so that way they're in an as-built orientation. We use align, we can align components, and we can do things.
Alright, I gotta do align. That's what's going on here. So align here. So is all this normal? What the freak? Guess it is. So align. Core line. Regular line.
Things like select them, move, copy, and alignment tools if we want to put them into their correct location.
Because modify. And then we want to line. Okay. Okay. Wow.
For example, when we use align, we can align components, and we can do things like select individual faces, and we can make those faces in alignment. We can capture its position directly from here, and we can also use tools like align to go from a single point location, so for example the center here, to the center, to go for its position directly from here, and we can also use tools like align to go from a directly from here, and we can also use tools like align to go from a single point location, so for example the center here, to the center here. This will allow us to pre-position these components so that way they're in an as-built orientation. However, this is not required when we're using joints. If we go to assemble and we select joint, we simply need to determine the motion, in this case rigid, and the location that we want everything to be placed together. Now in our case, the end of our pin is going to be at the end of this bore. Now those two are rigid, which means if we move the piston, the pin is going to go with it. So once again, there are options to use things like align, so that way we get all the components in their correct location, but we can also simply select the appropriate location when we're using a joint tool. Between the piston on the inside, and we have a connecting rod to be 20 millimeters, and take a look and see the width of the inside of this is going to be 20 millimeters, and if we measure the outside distance of the connecting rod, we can see that this is exactly 20 millimeters. Now, in reality, generally we will have a small gap, and what that means is we can't use coincident, and we're creating a joint. For example, in this case, we'll be creating a revolute joint because we want it to revolve around a single axis. When we are picking our locations, we can hold down the control key, which will snap or lock its focus and allow us to select the center point of that pin, and we can do the same thing for the inside of this bore. Holding down the control key will lock its focus and allow us to navigate between available snap points. You can see
I didn't know that.
on the screen. We'll say OK, and now the piston is on the end of our connecting rod. Now the motion isn't quite right yet because there's another piece of this puzzle that we need to bring into view. Now that is going to be our cylinder. The piston is inside the cylinder now. It's in the correct orientation. So this means that we can use an as-built joint. Now the as-built joint, in this case, will allow us to use a joint that allows for motion vertically. Now, this could be a slider joint because we've already locked the rotation with the pin, or we could use a cylindrical joint that allows the piston to rotate freely while moving up and down. Now, either of these will work because it's going to respect all other degrees of freedom that we've placed on the assembly. But in our case, let's use a slider. This is going to be between the piston and the cylinder, and then we need to pick the axis. This will allow the piston to move up and down freely, which means that once we rotate the crank, now the piston is going to be behaving as we would expect in the real
Maybe
world. Now, once again, we're
I
doing
need to
this
implement
with
as build
Joints
joints.
allow us to define the degrees of freedom of our mechanical components by determining where that location is, that they should be moving relative to each other, and determining how many degrees of freedom we want in translation and rotation. There are several other options inside of Fusion. For example, we have access to what's called a contact set. Now, contact sets allow us to make use of physical contacts between solid bodies. If we're going to go ahead and take a look at this assembly, as we move this top pin here, it's not doing anything because it's free to pass through other solid bodies. However, if we enable all contacts and we begin to move it, that solid body contact between components will begin to push the other components. And we can analyze this by going to a motion study to pass through other solid bodies. However, if we enable all contacts and we begin to move,
You just log? Damn. Holy. Holy moly. No way. No way. Are we for real right now? Oh, that's so cool. That's so cool. Okay, okay. Let's try again. Let's build joints. That one.
Fusion, I was about to say that I love you, but never mind. Fusion was said I love you, but never mind, brother. I kinda hate you. So we can do a line. Uh, God, I hate this. Oh, my eyes. My eyes hurt. Oh, let's build joints, please. Please. Edit. A for you. Continue. Oh my god. Please do something about this. How much?
Move it. That solid body contact between components will begin to push the other components. And we can analyze this by going to a motion study, selecting our joint, and allowing our joint to rotate 360 degrees. And what we're going to do is simply say at this point, we want to rotate 360 degrees, and then we can play the animation back, watching it move through. I'm going to reduce the speed and allow it to loop through, and play the animation, watching it move as we go. So this is a great way for us to bring another level of mechanical motion into a design where joints just aren't the right option. Now, if you're trying to do this inside of SolidWorks, you have to do this with the move command and enable those physics or those contact sets that happen during the move only. In Fusion, contact sets can be enabled and disabled at any point in time, and simply dragging things around on the screen will allow you to enable and access those contacts. So this is a great option when you're taking a look at things like complex gear assemblies that maybe don't have the best option for applying joints. Now, as we take a look at our options, we do also have things like tangent relationship and motion links. So if we're using a revolute and a slider joint together, we can determine the relationship or the ratio between movements of those joints. There are many options when you're working inside of Fusion to create that mechanical motion, but the main thing here that we need to understand is that we're locking down the degrees of freedom between components rather than doing that individually with things like coincident and concentric constraints. We're able to put joints on assemblies and allow them to move freely based on their degrees of freedom. Hopefully this makes sense, and if you have any questions, please leave them in the comment section below. Thanks for watching.
Oh. This thing is way too long, motherfucker. Way too long. Oh my god, I'm so sleepy. Oh my god. I just slept for like a minute. I'm tweaking. Oof, 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 oof. How
There
so?
are a lot of CAD programs out there, and because of all the convolutions and all the craziness, it's really not easy to figure out which one works for you, especially if you're at home trying to just make something. There are a lot of free versions, but the real question is, are they worth messing with? And if those are not worth messing with, should you dive into a subscription service for a more professional CAD suite that could get you.
Welcome to live stream number 139. Alright, enough of all this. Inside of Fusion 3, or the wheel versus this part here, this imported two things together, and then these two faces are now mated together. So this hole, and there's different ways I can do this. If we grab this line right here, we can spin it around like this. If we can scroll this around here, then we can work around with that. Now, don't want to finish quite yet because that would be silly. That would be a good place to stop. Now I want to see if I can't get myself into more stuff to show you. One of the things I noticed with this model that I brought in was that there's no screw going through. There needs to be a bolt in here. So again, just so we can kind of like reinforce this whole joint thing, so let's go to the McMaster car. Open that up. I'm going to select a bolt screw here. I'm going to select a hex screw, and I'm going to go metric, and I'm going to select an 8mm. And I checked this beforehand, so I know that a 45 would probably work. 45. Select this one. Product details. Go down, download a step file. Let's save. That should bring that screw in there. Move that out of the way. I always drag it out of the way of the handle there. Looks good. So let's put that one in place. So I'm going to go over here, go to join. Capture position is fine with me. Hover over the center here, and again, you get all these different points. I'm going to hold down Control or Command on the Mac and select that center, and then I'm going to move over to this edge right here. Make sure that it snaps into the right edge that I want here, and you will see that that gets in there. And that is rigid, right? I'm not going to try to make it spinning around or anything like that. So there we have a bolt on it, and then we need a nut, because that would be annoying if it didn't. Some kind of a nut. What did I select again? Hex nut. This should probably be washers and all those kind of things in there, but you know me. Shortcuts. Some kind of a nut here. Blah 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 blah.
Oh, dude, you know what I'm gonna do? I'm gonna take a nap really quick, and then I'll come back. So So right now I'm gonna take a nap. The nap is gonna be like 30 minutes maybe. And then I'll come back in 30 minutes, and then we can restart the clock again. Stop the clock.
Save that one. And that comes
Hold
in
up.
there. Okay. And again, joint. Hover over the face on the part that you want to move. Say, we can actually insert. So, so I hope that this doesn't. I really hope that it'll confuse anything. Now go in and add that joint. That you noticed here though is the intersection points that are in here. Right. So I might just choose to say, all right, I want to select that
Hey,
corner
wait.
there, and then I can
I
go
got
over.
I gotta power this through. I don't wanna take a nap right now. Oh my god.
You only get the one part moving. The whole assembly don't come with it until you hit OK. But now you can kind of like rotate it around 270 degrees and hit OK, and then you will see the poster come through the whole and select that corner right, and then I can go over like that one part right there. Boom, and you only get the one part moving. The whole assembly don't come with it until you hit OK. But now you can kind of like rotate it around 270 degrees and hit OK.
Okay, I fixed. So I fixed it, and now I have to apply the heat set, and then I should be mostly done. Um, info doc. So I'm just gonna apply the heat set really quick, and aside from that, find lag, implement heat set, play we are doing. Alright, I really. So I'm gonna implement that. The heat set. Okay, so I'll try to understand it. Okay. So what I'm gonna do now is I'm gonna isolate. I'm gonna isolate some model. Alright. So we have. Okay, so I'm gonna go to ChatGPT. Yeah, I cannot really figure this out. Well, I can, but right now I'm too tired. I'm too tired. Insert screws in net support. Okay, so I'm gonna look at the inspect button. Look at the radius. The radius is 0.07679 inches. And then what? This.
height is 0.9, and give me the screw and the headset that I need to use. Here we go. Okay, so hold that. And he said, the new MK Master. Okay. Wow. It gave to me precisely. Okay. So what I'm gonna do is I'm gonna look at this. I'm gonna go for a small break. 3 minute break right now. 3 minutes timer. I'm gonna come back in 3 minutes really quick. I just need to eat something. Okay, I'm back. Let me hit my standards really quick and figure out what to do. What to do.
Okay. Hmm. Let me see what ChatGPT is saying. They are work out. Mm-hmm. Mm-hmm. Okay. Close. Alright. So right now I got that. Let me see if I got all my screws. Oh. Okay. Okay. Mhm. Oh. And then the other one is the hmm copy. Control V. Download. Mm, no way. It's too big. It's too big. It's way too big. What the freak? It's way too big. Mm, yep. Way too big. Mm, is it supposed to fit? Ugh, I don't even know. Uh, M3 dress size. A we for real. They all for cat. They all. And 30 point. Oof. The heat set for the screw does not seem to be right. F50. Right. So you know what? For now, I'll save these and I'll work on my Arduino.
Welcome Arduino, and we'll see you next time. And more
box. Okay, so I just gave it a label. So it's gonna tell me what is inside before even opening the box. So right now by just reading this, okay, this has forget about this for now. Okay, so I want you to very look at this. Let me bring it up close here. So if you look at it right now, can you see how much I stress the GND? Like, it really looks really bad. This is, by the way, the GND. All these three wires are connected to GND. Okay, so what can I do to fix this? So let me just bring an extra wire right here. Okay, an extra wire. Let me zoom out right now for now. There we go. So I have this extra wire. What I'm gonna do is let me just remove these three GND pins for now. Before actually building the circuit, what do I want to do? I want to turn it off. I want to turn my Arduino off. First build, and then we upload, and then we run it. Okay, so got my GND pin right here, connected, connect the GND pin. If you cannot see it, I'm connected to the GND pin. All right, now what do I want to do? Okay, so I'm going to use this vertical stripe. Can you see it points to negative? There's negative and positive right here. I'm just going to use the negative one as this just again convention. Right, so I'm connected to this one. So as I said again, when it comes to breadboards, the edge ones are connected all the way vertically. So I can basically do is what? I can just connect it to this one, the vertical line again. The same for this one. Use this vertical line for the GND pins, and this one for the GND pin. I'm going to use a vertical one. There we go. Now it looks more nice, okay? So let me just, again, turn on my Arduino and run this. Everything should be working normal. Let's check it out first. Okay, so 5 seconds. There we go. Right, it's working really, really great. Okay, so
Oh
let's say I
wait,
have a
wait,
problem.
wait,
I
wait,
have to wait
wait.
for like 5 seconds. And I just say it's just too long. And I just want to reduce this to 3 seconds, okay?
I don't know if I
So
want
what,
to
what
share
should
my
I do?
screen right now.
I want to change the green and red to 3 seconds. I like the yellow one. It's 1 second. It feels not only that too, I have to go back to red, change it to 3000 again. Okay. I have to upload it. It's gonna work for 3 seconds now. But let's just check it out. Working. Okay, there we go. It's working. Okay, it's a bit faster now. Let me just count again. 1, 2, 3. Change over. Okay, there we go. It's working perfectly. Alright. But I have to go change it to two separate places. So I have to go right here and change this to 3000. Again, 3 seconds. So I have to go right here again and change this to 3000. Just think of me having lots and lots and lots of LEDs.
Oh, it's
Instead
a
of
lot of
5
work,
places, I'm gonna have to go
dude.
change it what? 6 places. I don't want that to happen. So
Mm.
how do I do avoid this type of mistake? So we're gonna learn something called variables. Alright? So first before learning about variables, let's talk about this box. So I have a box right here, okay? So
Let me see.
this box,
Hello?
no label on it. You do not know
Alright,
what is inside
alright.
until you open it. When you
Hello?
open it, you know what's inside, okay?
Ooh.
So it has no label.
I'm just checking my voice right now.
But to
Okay,
save us this
so
effort,
the
let's say I
microphone
just
still
checked it
works.
out, labeled it right here, and named it microphone box.
Okay, we're in variables right now.
Avoid this type of mistake. So we're gonna learn something called variables.
I recall using variables. Nice.
Right? So first before learning about variables, let's talk about this box. So I have a box right here, okay? So this box, no label on it. You do not know what is inside until you open it. When you open it, you know what's inside, okay? So it has no label again. It's just empty. But to save us this effort, and let's say I just checked it and labeled it right here and named it microphone box. Okay, so I just gave it a label. So it's gonna tell me what is inside before even opening the box. So right now, by just reading this, I can Okay, this has some mic equivalents inside of here, right? Okay, this has mic equivalents before even what? Opening. Alright, so this is the nice thing about variables. So what they do is basically refer to things, alright? So they just basically refer to our data. So we can refer to our data without actually changing anything about our data. Our label does not change anything about our box, right? It doesn't change anything. All it does is what? All it does is reference to our box. What is inside the box? That's just what it tells us. So how do we set up variables here? And we're actually gonna see even a second purpose of variables. The first one is to reference things. We're gonna check the second use of variables. So let me go right here. Let's see how you set up variables here. So all you need to do is go right here and use the keyword let, right? I'm going to use the keyword let here. So all you need to do is write down a name. So let's say I want this to be delay time. So I just write down delay underscore time. Okay. So I'm going to set this to 3000 and close this. Let me just verify if this is correct. And it says no, it's not. It does not name the type. Okay. So right here, all we need to do is go right here and say let delay time. We do want it here. Let does not name the type. So you might be wondering, for those of you who are using JavaScript and Node, that we have to tell it what type of data we're putting inside. Right here, we're putting what? We're putting an integer. Alright, so we have to let it know the type of data that we're storing. Right? We're gonna say is integer. Basically, it's an integer number. So let me just verify this again. Should be working pretty fine now. Can you guys see it? So we have to tell it the type. So when you're using Arduino, you're gonna have to tell it the type of variable that we're using. So in this case, it's an integer I'm defining here, and obviously I'm gonna give it a name. So I'm gonna call this delay time. Again, this has nothing special on it, so I can just even call it something else that is unrelated to it. I can just say, you know what, screw you, and I can just say phone, or I can just say anything. You get it. But I'm gonna obviously put delay time because that's what is the use of variables, to give us rightful information of what this is. So even before somebody really to give you, you know what, we're telling variables need to do a second correct. One thing do is things. We're gonna check the second use of variables. So let me go right here. Let's see how you set up variables. So all you need to do is go right here
Okay.
and use the keyword let, correct? I'm going to use the keyword let here. So all you need to do is write down a name. So let's say I want this to be delay time. So I just write down delay underscore time. Okay. So I'm gonna set this to
Delay
3000
underscore time
and close this. Let me just verify if
equal
this is correct.
3000.
And it says no, it's not. It does not name the type. Okay. So right here, all we need to do is go right here and say let delay time. We do want it here. Let does
Is
not
it
name the type.
JavaScript? What? I
So
thought it was C++.
you might be
Wait.
wondering, for those of you,
Which programming language is was it Arduino? ID. Original C++.
who are using
Okay.
JavaScript and all that, we have to tell it what type of data we're putting inside. Right here, we're putting what? We're putting an integer. Alright? So we have to let it know the type of data that we're storing. Right? We're gonna say is integer. Basically, it's an integer number. So let me just verify this again. Should be working pretty fine now. Can you guys see it? So we have to tell it the type. So when you're using Arduino, you're gonna have to tell it the type of variable that we're using.
Oh.
So in this case, it's an integer I'm defining here, and
Okay,
obviously I'm
so
gonna
what do
give
you
it a
need
name.
it
So
for?
I'm gonna call this delay. Again, let it know the type of data that we're storing. Right? We're gonna say is int. Right? Data by using JavaScript and all that. We have to tell it what type of so correct, and it says no, it's not. It does not name the type. Okay, so right here, all we need to do is go right here and say let delay time. We do want it here. Let does not name the type. So you might be wondering, for those of you who are using JavaScript and all that, we have to tell it what type of data we're putting inside. Right again should be working pretty fine now. Can you guys see it? So we have to tell it the type. So when you're using Arduino, you're gonna have to tell it the type, the variable that we're using. So in this case, it's an integer I'm defining here, and obviously I'm gonna give it a name. So I'm gonna call this delay time. Again, this has nothing special on it, so I can just even call it something else that is unrelated to it. I can just say, you know what, it's green, or I can just say phone, or I can just say anything. You get me. But I'm gonna obviously put delay time because that's what is the use of variables to give us rightful information of what this is. So even before somebody reading my code, they can understand. They can understand before reading this code is that, oh, this is delay time. This is supposed to be the time that is gonna delay inside. Obviously, this again is
Oh, I'm so
okay.
tired.
So I'm gonna go say
12 more
delay time. Let's
minutes.
set it to 3,000. All right. So we'll just set it to 3,000. So I'm gonna remove it. This delay time right here. So I'm gonna be using it. How do I use it? I just use it as a normal thing. I'm just gonna say delay time. I already defined it. I can use it multiple times. All right. All right. Also for red, I'm gonna go right here and use delay time underscore time. All right. Perfect. That's all I need to do. If I verify this right now, I don't get any error. Right. Everything's sounding great. If I upload this, as I said again, the variable does not change a thing about what it's referencing. So I earlier said 3,000 here, and basically what it's just doing is delay time is equal to 3,000 here. So it's basically putting 3,000. The computer is manually putting 3,000 here, right, instead of delay time. That's just what basically it does. So second usage of variables here is that, you know what, this is a bit too fast for me. This thing is just really fast. This is going 3 seconds, and then 1 second off, and then 3 seconds. This is very fast for me. I just want to make it 4 seconds. All right, so I can just do right here is just change it from one spot. I don't have to go multiple spots to change it. I've defined it once. I can do is just change it from one spot and say, you know what, that's what I want. Let me just verify this. Let me upload this. I want it to be 4 seconds. I want it to be in the middle. I don't want it to be too slow. I don't want it to be too fast. All right. So look at this. I upload this right now. It goes 4 seconds. So let me count this 1, 2, 3, 4. All right, there we go. So it goes for 4 seconds. All right. That's all you need to do when it comes to variables. That's why we use them a lot. All right. So instead of using pin 7 right here, just say go one take it in 1 second off, and then 3 seconds. This is very fast for me. I just want to make it 4 seconds. All right. So I can just do right here is just change it from one spot. I don't have to go multiple spots to change it. I've defined it once. I can do is just change it from one spot and say, you know what, that's what I want. Let me just verify this. Let me upload this. I want it to be 4 seconds. I want it to be in the middle. I don't want it to be too slow. I don't want it to be too fast. All right. So look at this. I upload this right now. It goes 4 seconds. So let me count this 1, 2, 3, 4. All right, there we go. So it goes for 4 seconds. All right. That's all you need to do when it comes to variables. That's why we use them a lot. All right. So instead of using pin 7 right here, just saying 749, okay, I can change it again to for somebody who does not know what I'm writing down. Before somebody even knows what I'm writing down right here, by just defining these variables, I just save them the time from reading the code. It can also work for yourself when you come back to this code, right? So I can just say is, you know what, I can call this digital pin digital underscore pin equal to, let's say again we have 7 right here, so digital pin, let me just say 7 right here, right? Let me say digital pin 7 underscore 7. There we go. Then I can write this down for 4, write this down for 9, 9 here, 4 here. There we go. And obviously replace this digital pins right here. So I'm just repeating I'm repeating 7 right here on pin mode, and also on digital write. I'm repeating them over and over again. Can you guys see the difference right now? So let's say I'm changing the pin. I have to change it at 3 separate places. I don't want that to happen. So all I have to do right now is do the exactly same thing. I'm gonna write down digital pin 7. It's gonna have to look a little differently. I'm gonna say digital pin full, and then digital pin what? Digital 9. Okay.
I had to write down the integer pin. I don't need to write down that. I understand what's going on, but just in case. 7 int digital 2 equal to int digital pin 3 3 equal to 3. Okay. 1 2 3 Oh, oh my god. Okay, come on. Okay. Digital pin 1. Digital pin 2. Digital pin 3. Say okay and survive.
And digital pin what? Digital 9. Okay, so I'm just gonna replace this again. So one thing you guys need to know is, okay, so I'm just gonna replace this again. So one thing you guys need to know is by using Control D or Command D, you can just select the same number over again. So you can select the same thing over again. Say I only selected 7 right now, and I just selected the 7 from the digital pin 7 right here. So you need to be careful. So okay, what I'm gonna do is select this 2 7 right here, and I can edit them at the same time. Okay, edit this at the same time. There you go. And I can edit them. So you need to be careful. So okay, what I'm gonna do is select this 2 7 right here, and I can edit them at the same time. Okay, edit this at the same time. There you go. And I can edit them. So you need to be careful. So okay, what I'm gonna do is select this 2 7 right here, and I can edit them at the same time. Okay, edit this at the same time. There you go. When it comes to 4, I only have 2 fours right now left. Use this, and yeah, set this. Comes get here. Say I only selected 7. You can just select the same thing. You guys need to know is by using Control D or Command D, you can just select the same number over again. So you can select the same thing over again. Say I only selected 7 right now, and I just selected the 7 from the digital pin 7 right here. So you need to be careful. So okay, what I'm gonna do is select this 2 7 right here, and I can edit them at the same time. Okay, edit this at the same time. There you go. When it comes to 4, I only have 2 fours right now left. Use this, and yeah, set this to digital pin 4. And when it comes to 9, I can again use Control D, select 2, then digital pin 9. There you go. It's not supposed to change anything about our code, but it should make it what? A whole lot nicer and clean, alright? So let me verify this again if it's working properly. Okay, everything seems fine. Let me upload it. And let's check if everything is working properly as it should. Alright, nice. Okay, that's good. It's working really, really nice. Alright, again, what point? I can again use Control D. It's the 4. I only have 2 fours right now left. Use this, and again, set this to digital pin 4. And when it comes to 9, I can again use Control D, select 2, then digital pin 9. There you go. It's not supposed to change anything about our code, but it should make it what? A whole lot nicer and clean, alright? So let me verify this again if it's working properly. Okay, everything seems fine. Let me upload it. And let's check if everything is working properly as it should. Alright, nice. Okay, that's good. It's working really, really nice. So you guys learned about variables. So again, as I said, one thing you should know about variables is, as I said again, one thing you should know about variables is what? They do not change anything. All they do is what? Reference. Again, like I talked about the box. The label on the box just basically reference what is inside of the box, but nothing more than that, alright? So that's all it comes to variables. So all they do is just refer data. They just make it easier and cleaner to store data, alright? Alright, with that in mind, let's move to the next section.
I was making sure there's like a must replay part.
So at first, we began with the 5 volt right here. We began with the 5 volt, and we built a simple LED circuit.
Okay,
Afterwards, we
4 more
moved
minutes,
to the pins
guys.
right here, and what we did is again build a traffic light. Okay. So what are these pins marked with an A and a number next to them? We're gonna check them out in the next few sections. By the way, these are called analog pins. So in the next few sections, we're actually gonna see
Okay. We there.
This is a H-bridge motor driver. It's a circuit used to control motors, so you gotta know how they work. When current flows through a motor, it spins. If the current is reversed, the spin is reversed.
In other words, we use these digital pins right here.
That's
So last time I talked about how I made my circuits like this, it got quite a lot of attention. So this time
what
around,
the
I'm going to
freak?
answer some of you guys' questions. I'm going to tell you which wire I use. It doesn't take a genius to figure out how I'm bending these wires. I'm using the pliers. However, some of these bends, they're not so obvious. First, I get the wire straight. I roll it out, and I use solid core wire. Now, it's really important that you get this part down. I call these once-over bends. These bends go over the wire by the thickness of the wire. First, you got to bend straight up, and then you just hang over the pliers in whichever direction you need to go. Now, the gauge of wire that you choose to use doesn't exactly matter, but for me, I use 22 gauge. In my opinion, it just looks the best. The last time I talked about how I made my circuits like this, it got quite a lot of attention. So this time around, I'm going to...
Some PC gamers prefer their mechanical keyboard.
Okay.
Alright, so let's recap what we've done so far. So at first, we began with the 5 volt right here. We began with the 5 volt and we built a simple LED circuit.
That's true.
Afterwards, we used these digital pins right here, and what we did is again build a traffic light. Okay, so what are these pins marked with an A and a number next to them? We're gonna check them out in the next few sections. By the way, these are called analog pins. So in the next few sections, we're actually gonna see the difference between analog pins and digital pins. Not only that too, but we're gonna see their purpose and why they are important in the Arduino world. So see you then.
Analog pins. So the analog pin, there's one over there and there's one over here. Okay.
Alright, so let me show you guys what I did right here. So what I basically did, right, is that I set up the basic 5 volt LED circuit. So we have a 5 volt right here connected to the red connecting wire, and then we have a resistor, and we have our LED, and then we go back to the GND with the black wire. That's what I did. That's what we did when we started this course. Okay, so let me go over to my screen right now, and let's start coding. So right here, let me first give this variable name. So I'm gonna say red pin.
Red pin.
We give it a number. Let's say we're using pin 4 right here. Analog pin 4. Let's just say that. Let's leave it by random. And right here, what we do is we did for digital pin. What we did was pin node. Then we put our what? Our pin, which pin it is, and then how do you want to use it? Do you want to use it as an output or as an input?
8 more
This will be
seconds.
sent out at the end of each run. Alright, that's what I did right here. But there is a problem.
Alright, guys.
Right here.
I think that's the end of the stream. I'm gonna do this next, and but when I stream back, I'm probably gonna finish all the analog pins. But
When
but
we're
you should
using
definitely do
these,
this, and see you next stream. See you guys.